So in this word problem, they tell us that an event planner is planning a party. It costs the planner a one-time fee of $35 to rent the venue, and then $10.25 per attendee. The event planner has a budget of $200. What is the greatest number of attendees possible without exceeding the budget? I realized I left off a 0 here. Let me see if I can get that in there. There we go. So I realized that based on this second sentence, it seems like they're wanting me to set up some sort of a linear expression. I've got a one-time fee of $35, and then I'm going to have to pay $10.25 per attendee. That's the rate per attendee. So if X is the number of attendees, this on the left side of this inequality would be the total cost to the party planner to run the event. Now, their budget is $200. So I need the total cost to stay less than or equal to $200. If I solve this inequality, I'm going to undo the order of operations, subtract 35 from both sides, undo this multiplication, divide both sides by 1025, and what I end up with is that X is going to have to stay less than or equal to 16.09. Now, think about what X represents here. X represents a certain number of people. I can't have 0.09 people. So I'm going to have to bump this down to 16. The most people that can be invited is going to be 16. If I go to 17, this inequality at the end here is not true, and therefore the inequality that I started with wouldn't be true, and that person would be over budget. Even if this was 16.9 rather than 16.09, I would still bump that value back down to 16 because going to that 17th person is going to push me slightly past the $200 budget. So it's not necessarily a rounding process that I'm using to go from X is less than or equal to 16.09 to a conclusion of 16. It is just a reasoning strategy that I'm using to make that judgment. Whatever's here is the biggest value that I can get to exactly $200. I can't go to that next whole number from that value.